Same model. Same data.
Split A, 87.3%. Split B, 71.6%.
Which number do you put in your report? That question is what this episode answers. Episode 17, Train Test Split and Cross-Validation. Why one score isn't enough and what to do instead. Train Test Split. 80% trains the model, 20% tests it. One split, one number. Sounds clean.
But what if that 20% happened to be easy?
Or hard? The model didn't change. The split did.
You're measuring the split, not the model.
A score from one split is an anecdote, not evidence. Before cross-validation, understand the three zones. Train, the model learns from this, 60%. Validation, tune hyperparameters here. Pick the best model, 20%.
Test, one final check. Never touched during training or tuning.
If you touch the test set twice, it becomes a validation set.
That rule is non-negotiable.
K-Fold cross-validation fixes the single split problem. Split your data into K equal folds. 5 is the standard.
Round 1, fold 1 is the test set. Train on folds 2 through 5. Round 2, fold 2 is the test set. Train on the others.
Repeat until every fold has been the test set exactly once.
You get 5 scores. Report the mean and the standard deviation.
Mean of 0.84. Standard deviation of 0.016.
That's a number you can defend, not one you got lucky on.
Plain K-fold splits rows randomly. That's a problem for classification.
If only 5% of your data is class 1, fraud, cancer, churn. Some folds might get 0 positives. Others get 12%.
Your scores swing wildly, not because of the model, because of the split.
Stratified K-Fold preserves the class ratio in every fold. Sklearn's default in cross_val_score for classifiers. Always use it.
Data leakage is when information from the test fold contaminates training.
The most common way, scaling your data before splitting.
Standard scalar fit on all data, including test rows, then you split.
The scalar now knows the test set's mean and variance.
Your CV score looks great. In production, the model fails.
The fix, fit preprocessing only on training folds. Use a pipeline. Pipeline applies every step inside each fold. Leakage gone. In code, this is 4 lines of setup and 1 function call. Wrap your scalar and model in make_pipeline, order matters. Create a stratified K-fold with 5 splits, shuffled, fixed seed. Call cross_val_score. Pass the pipeline your data, the CV object. Set scoring to F1, not accuracy.
Print the mean and standard deviation. That's your honest score. If this clicked, subscribe. Bias variance trade-off is next. Let's run both on the tuned XGBoost from episode 15. Single split, seed 42. F1 of 0.83.
Saudzafine. Change seed to 7. 0.71.
12-point difference. Same model. Same data. Different luck. Cross-validation. 5-fold scores. Mean 0.812. Standard deviation 0.018. Stable and honest. 0.812 is the number you put in your report. StratifiedKFold gives you other CV strategies for specific situations. Stratified K-Fold. Classification with imbalanced classes. Repeated K-Fold. Run multiple times for a lower variance estimate. Leave one out. N folds equal to dataset size. Unbiased, very slow. Time series split. Ordered data only. Never shuffle past and future. Group K-Fold. Keep all samples from one entity in the same fold. How do you pick the right strategy? Large dataset, over 50,000 rows, one split is fine. Small or medium dataset, under 10,000, always do K-Fold. Classification with imbalanced classes. Stratified K-Fold. Time-ordered data. Time series split. No exceptions. No shuffle. In practice, default to stratified K-Fold with 5 splits for classification.
Quick recap before we go. Single split, one number. Might be lucky, might not be.
Three-way split, train validation test. Touch test once.
K-fold, K-scores. Report mean plus or minus standard deviation. Stratified, class ratio preserved in every fold.
Leakage. Pre-processing outside the fold contaminates your score.
Pipeline the fix. Always wrap pre-processing with your model.
Where we are in the series. We've tuned a model, evaluated it properly, and now we trust our CV score.
Episode 18, Bias Variance Trade-off, Why Your Model Underfit or Overfit.
Learning curves. Diagnosing with data. We'll build it from scratch. Episode 18, Bias Variance Trade-off Explained. What bias means and why underfitting wastes your data.
What variance means and why overfitting betrays you.
Learning curves. Diagnosing your model without guessing.
Subscribe so you don't miss it. Your challenge task for this episode.
Load any binary classification dataset. Evaluate a logistic regression with a single split seed 42.
Then evaluate the same model with 5-fold stratified K-fold. Change the seed on the single split. How much does F1 move?
Bonus. Wrap a standard scaler in a pipeline and rerun cross-validation.
Does leakage actually change your score here?
Solution is in the repo. Think before you look. Split A said 87. Split B said 71.
Cross-validation said 81.2 plus or minus 1.8.
Report the number you earned. Episode 18, Bias Variance Trade-off drops next. Subscribe. Comment below, what split strategy were you using before this?